This video is a continuation of a previous set of videos on this Ford EcoBoost engine. We are in the assembly process. We are getting the rest of the motor put back together. We're going to go ahead and cover some bearing talk and get the timing components installed and then get it ready to put in the truck. So stay tuned and we will get right to the video. Okay, so I have you guys here. You can see the bottom of the motor access. Obviously, we have the crank sitting down here, and then I have a couple pieces of paper. So these Ford engines are very, very picky with their bearings. At least it appears as though at first. So what you have to do is there's a block number, and the block number is located one side or the other here. There, that side. It's located over on this side, and I'll give you a view of that here in a minute. But the crank number itself is actually on the back of the crank. So there's a little tag right here, and this tag is where you have to look for the number to find out what bearing sizes you need according to the manufacturer or the grinder of the crank. And what you have to do is you have to take the numbers and letters, and so this particular one, the crank itself is right here. It's a KKKI, so you have to take these letters, and then this is on the block. This is how it looks pretty much. So there's a LLLM, and then there's a letter after the first two L's, a letter and then a number, and then in between the last L and M on this block, there's a 764. Now I'm not sure what the relevance of these numbers, letters are at the moment, but you take these and you cross them on a grid. So what you have is you have a square grid or rectangle grid. It might be a little bit longer. It depends on what you print it as, and I didn't print it, but you have letters up on top, letters on the side, and then you have to take and cross it. So the top letters are the block number. So you take like the first K. The first K would be the first main bearing, and on the blocks will be the first journal here, and that you find up here. You find the K, and there's a couple different graphs because there's 27 letters in the alphabet, and they use almost all of them, if not all of them. But you find the K, then you find the L, because that's number 1 on the grind of the crank. So it's 1, 2, 3, 4, 1, 2, 3, 4, and you take the L and you find it over on this side, and you take those two and you cross them, you find your number. And that's what I've written down on this piece of paper here. So it's a bearing grade, and the number 1 is 2 is what I need according to what I looked up. Number 2, I need 2 on both. Number 3, I need 2 on both. And number 4, I need a 2, 3. So what I'm finding is that number 4, which would be this is the back, I would need a different one here. And according to both cranks, it looks like they match up the same numbers, but I measured a little bit difference of main bearings. Now the rod bearings do kind of the same thing, but the rod bearings, instead of doing a letter number type or a letter graph system, they do all numbers. So you have to measure the rod journal inside the rod, and then you have to measure the rod journal on the crank, and once you have those measurements, you cross them and pinpoint where it goes. Now considering the bearings condition, I'm not worried about the rods being stretched, but if you have bearings that are worn kind of goofy on the side or goofy on one end and not on the side, you have to worry about being stretched out. So be sure that you pay attention to that. These are not worn at all. I'm not too worried about stretch. I have no easy way to measure these because they're still in the block. It's a chance I'm willing to take on this particular vehicle, given the particular circumstances, which I don't expect most people to have. But considering that, I took both cranks and I measured them, and they are 0.2 of a thousandths. So 0.0002 to 3 of a thousandths different. Now the new crank is tighter, so it's a little bit bigger by that amount, but given that it's a little bit bigger by that amount, it still shows up the same on the chart. Now you're supposed to measure these in millimeters. I measured it in thousandths because that's the only instruments I have available, so I just did a conversion in the good old Google converter or whatever thing, and the conversion came out a little bit different in metric, in millimeters, enough so that it moved me to a different section on the graph. But even though I'm on a different section of the graph, it still calls for the same bearing. So I'd imagine that's the amount of slop in the bearing that they're allowed to work with. So I think the rods will be fine. Now, the mains, we're calling for 2s on 1 through 3, and then the 4 is a 2-3. I can't tell all of them what they are, but I can see a number 2. So if you can see that, there's a number 2 there, and I'm positive that's the grade, because that's the only place I can find something like that. So, given it's calling for 1 through 3 being all 2s, and 4 being a 2-3, I have all 2s across here. So that's upper. So I think this is upper-lower, and that would mean that I have all 2s on all uppers, and the last one here, the lower, should be a 3 per the comparison of crank rod combo. And I am not positive if it's a 3 or not. It looks like it might be a 3, but it's like kind of faded and goofy, and I might replace this one anyway, so I would end up just getting a 3 if I get this one. But what I'm going to do before I go any bit further is, just in case I need different main bearings or rod bearings, I'm going to go ahead, put the crank in, mock everything up, and get some plastic gauge on everything and see what the clearances currently are. And I will bring you guys right back once I have all the plastic gauge marked and in place, so you guys can see what that looks like, and we can see if I'm going to need to order different bearings or not. Okay, so I have all the plastic gauge on the mains taken care of. I still got to do the rod caps, but I'm going to do those separate because I'm hoping that I can actually bolt the mains down before I go messing around with the rods, because once I do the rods, if one's good, I'm not going to take it off again after I put it back on. So my goal here is to obviously get the mains taken care of first. Now, if you have any curiosity as to how to properly use plastic gauge, now plastic gauge can be fairly accurate. People claim it's totally inaccurate, but that's more on the user's behalf that the problem persists. And I go through and cover all that on the video up in the corner. So be sure, if you are interested in learning more about that, at the end of this video, go ahead and click that little eye in the corner there, and it will show you all the little bearing tricks that I have learned over the years, what makes it inconsistent, what works, what doesn't, what not to do, that kind of thing. So plastic gauge is a bit finicky, but if you use it right, it will work, at least accurate enough to do what you need to do to get the job done. So I have here 4 plastic gauges sitting in place. Now what I need is a specification between 1 to 1 point, well, it wouldn't be a point, so 1/6 for a thousandth of an inch, so it'd be 0.001 to 0.0016 is what Ford calls for specification. Now that's assuming, of course, using factory oil, so on and so forth. So I have here, a little chunk of debris on there, there we go. I have here a plastic gauge indicator and my plastic gauge in place for the plastic gauge that I used, and I'm going to go ahead and rattle off what each one of these is reading. And again, I show in that other video clip how to kind of justify where it is. So looking at this one here, this is going to be bearing number 4. I have around 2 to 1/8 to 2, something like that, for thousandths of an inch, of course. So I'm gonna make it like a point of a thousandths, just to make it talking easier at least. That's not correct terminology, but that's how I'm gonna go ahead and rattle it off here. So this would be 1.8 to 2 thousandths. This one here is gonna be 1.4 to 1.5 thousandths. This one's gonna be about 1.5 thousandths, and this one here, a little looser, it's gonna be about 1.9 or 1.8 to 2 thousandths. So basically these two end ones are a little bit looser than Ford specification, and normally anybody else who's running normal oil, Ford weight oil, I would say this is not acceptable. Go ahead and get the bearings. I'm probably going to go ahead and get the bearings anyway for at least this one. Maybe I'll just order that one while I'm at it. But the fact of the matter is, this would be acceptable in this motor because this customer runs 10W40 rather than 5W30, and that little extra room for the oil to move would be perfectly fine. So I also have to check the end play here, and I'm going to do that once the crank's actually bolted into place. So once I have all the mains into place, I'm going to check the end play, and the end play is that little thunking that you hear, and it's the cranks in play this direction. So that is supposed to be 6, was it 6? I think it was 6 thousandths to 12 thousandths. I'll have to double check, don't quote me on that. For surely 7 to 12 thousandths, you'll be fine within that range. I know it went up to a little over 12 thousandths, and definitely under 6 or 7 thousandths. So somewhere between 7 and 12 thousandths, you'll be perfectly fine. Honestly, judging from experience and how this feels, it feels like it's right at about 8 to 9 thousandths. So I'll get my indicator on there once I have the cap in place. So I'm going to go ahead, get this taken care of the rest of the way, then I'm going to get at the rods, and we will bring you right back when I got the rods measured out and figured out. So I took the time to get all the rods taken care of, checked, you know, that kind of drill. Now I have one left here. I just wanted to make a quick comment on things. The factory calls for just using motor oil. That's what this is for the lubrication of the bearings, but I actually prefer to use an assembly lube for bearings just because then I know it's not going to dry start. So that's kind of a nice thing to do as a little bit of an extra, I guess you could call it. But I have the last one here just to show that there's grease in it, and then here is the bearing. Now I didn't bring you to show you all the measurements of each individual bearing because I could only do a couple at a time, and it was real time consuming because I don't want to turn the crank too much. And the reason I don't want to turn the crank too much is I want to be very cautious when I'm turning it. I want to make sure that as I turn, I can do it by hand and I go slow, because I want to make sure that I don't hit a valve and dent the valve or bend the valve, because there are a couple valves open since the timing is not attached yet. So what I'm going to go ahead and do is, while on camera here, I'm going to go ahead and take this last one and lube the threads with a little engine oil because of torquing things down. Lube the head with a little bit of engine oil. And then we're going to go ahead and set this down in place. Now, if you remember, I marked this side of the cap with the number per the cylinder it goes on. Another thing, these little tangs, they always go on the same side as each other, at least as far as I'm concerned. There might be a motor that's different, but every motor I've seen, they always go on the same side, and this is one of those. Now, you can, since this is a cracked rod, kind of verify per the broken section where it's supposed to be sitting. So what I can do is I can inspect the hills and valleys that are inside here and compare it to another side. So if there's any attribute that stands out, I can easily decipher that I'm on the right one. I have a line going across here that looks like a big crack, and then I have a spot that's kind of a ledge there that would match that if I were to put it on. So I know this is going on the right rod and in the right direction. They break different every time, so no matter what you do, you cannot switch rod caps on these motors or you will have one hell of a problem. So be sure to be very cautious about that. Now I have all the mains in place, but I do not have them torqued down, and I don't have the new bolts on the mains, just in case something were to be strange with these rods. I want to get all the rods done first, because I can always lift up this crank a little bit to slide bearings in and out of the mains as needed. But I'm getting all the rods on, and then I'm going to go ahead and mess with the final step, which is going to be this thrust washer here. Now you notice I'm just lightly impacting these, and that's because these are torque to yield bolts, so I'm going to have to come back and torque them. I did not torque any of them yet, but I do plan to. So what I'm going to do is, once I come back here, I'm going to get all the timing components on, and once that's done, I'll be able to deal with all the bolts here and get all of them torqued down. I also have to attach this giant girdle assembly and torque those bolts as well. So that's another step to this project. It's kind of quite the project. Hopefully you're not having to do this on your own. Most likely a yard motor would be the best option, but if you are interested in doing this kind of project and you're watching this because of that, don't be judgmental and go to only Ford videos. Go ahead and check out my engine build on a Corvette that I did, because a lot of the same basic concepts, though the motor is much different. I go over really high detail in that motor build of various things. Plus I have other motors that I've done builds on, some Pontiac stuff and whatnot that'll be on my channel. So be sure to check some of those videos out if you're interested in motor building and you want to do it yourself, because I have a different set of tricks on every single build that I do. This is obviously not a build, this is a repair, but a lot of the same stuff still applies. So be sure to check them videos out, and yeah, I'm going to go ahead and get the valve train stuff figured out here. And if I run into any weird situation or steps and procedures, I'll just go ahead and cover it once I have it all together, unless it's weird enough that I have to cover it on the spot while I'm doing it. So I'm going to go ahead, get that assembled, and you guys will be right back, hopefully when I'm done assembling it. Alright, so I actually pretty sure I recall telling you guys that I would show you how to do the chain tensioner to compress them. So that's what I'm going to do now quick while I'm doing this timing chain component deal. And here it is. Here is the tensioner. So what we're going to do is we're going to place it in a vise here. Now, this one's a little screwy. I got this uneven thing going on here. And because of that, it's going to make it interesting trying to... Oh, there goes a bolt inside the motor I'll have to pick out. So because of that weird angle, I'm going to have to try and find the best possible position to set this into where it's not going to break something. Maybe I'll... There we go. That's what I'll do. I'll hang it off the edge here. So what we need to do is there is a tab here. I'm going to have to squeeze this. Oop. Now I, of course, pulled it out of there. So we'll go ahead and reset this quick for you guys. Apparently don't squeeze that unless you're ready for it. So what we're going to have to do is we're going to have to place this guy, this ring, inside this here first, since I popped it apart on accident. Way to go, huh? Oh, stop squeezing it. It'll help. There we go. Okay. Now I can set this guy. Oh boy, this is going to be fun. Interesting. Alright, so what I'm going to do is I'm going to go ahead and squeeze this and hold it in there like that, and then push this in. There we go. Now I'm getting somewhere. Okay, so now I'm going to go until it hits that first latch. There it is. Now I'm going to squeeze it so it can get past all the rest of these latches. If I feel any resistance, I got to stop because that means it's binding. There we go. I got quite a bit in there. I'll go ahead and bring this out as far as I can. See if I can get a little more out of it. Oop. Nope, feels like it's going to pop out of there. Okay, so now I have to grab a pin. Oh, I won't be able to slide it through there yet. It's got to go in further yet. Okay, and bring this in even further yet. Oh, there it was. It was just binding on the case half of the thing. It was stuck on this little ledge here. The vise was. Okay, now there's a pinhole right here that goes all the way through to this metal plate on the other side. And what I have to do is I have to run a pin through there to lock this into place. And whenever I do timing belts and timing chains, I always keep these little pins in my box just for this reason. I think they're the same size. I have different versions. No, same size, whatever. Either one will work. So I'm going to go ahead and put that in there. Now I can safely take this off. And now that it's out of the vise, it's nice and compressed and it'll go in the motor nice and easy. And then when I'm ready, I can pull this guy out and this will pop out. Alright, I haven't got all the tensioners on, but that's because I ran into a little bit of a thing that made me think it was good to address. So you can see I have this one on here. This is the one that you guys just saw me do the showing you how to do it, and I totally didn't know how to do it kind of a thing. But anyway, so that is that one. Now I went ahead and I put this tensioner on, or tensioner, not guide, the guide for the tensioner, so it sits right there like that. And I went to put that on, then I put this one on, then I went to go and torque my bolts down because I realized, or as soon as I went to do that, I realized that I can't do that because these two right here, you have to torque those before you can put the rest of it together. These two you can't access because the guide sits in the way of this one, and then this guide sits in the way of that one, so no matter what, you can't do that. Now, I did have these marks lined up to the marks that I made on here, and it actually went pretty smoothly. And then of course I can move the crank back and forth to give slack to either side of the chain that I need, and that's how I'm kind of doing that to make sure that these things can go in easy. And so I have to jump this chain one notch actually because it jumped on me. Okay, so you can see this one is actually pretty tight and fairly straight, and that's because I have the slack so that it is all on this side, so I can do that one. Now the reason I need all that slack on that side is this one has this huge ledge here, and that ledge causes a lot of problems for getting in there. You can't have the tensioner, oh, there it goes, it jumped. You can't have the tensioner in place there in order to get this in there. It will get in the way. So it makes it a little bit finicky there, so I wanted to make sure I brought that to our attention as well. I gotta sit here and play with this chain. And then for this one here, I also had to pull the pin after I had this torqued. I had to pull the pin in order to get this chain guide back on there because that pin is in the way of the chain guide. So now that I have that there, I'm going to go ahead and remove the slack from this side of the chain and put it on the other side of the chain just by turning the crank a little bit. Now I can go ahead and move on to this next one. Now this one has a slot here that slides in there, and you can see that pin would have definitely gotten in the way. But this one, they give you a lot more room to work with for getting it into position. So I'm going to play with that, and then once it's all done, I'll get you guys right back. I got to put the chain on the sprocket though. Now, one thing of note is these chains slip on these sprockets very easily. There's not much of teeth to bite. So if this system were to have anything go wrong where anything's a little bit too worn out, I could definitely see these chains jumping, causing bent valves and causing a whole array of problems. And this is supposed to be the updated, revised, better version of the timing chain that used to fail at 80 to 100K on these motors. So considering that, I doubt it's much of an improvement, but time will tell because this thing's still pretty new. Okay, so hypothetically speaking, I have all the bolts torqued down, and these guys are still in there, and the chain should stay in place, of course, hypothetically. Now, before I take these little bolts off, I am going to do one more quick double check to make sure all my little marks I made line up perfectly, because I do not whatsoever want this thing to be off at all. Okay, looks like I'm good, so I'm going to go ahead and start taking these guys out of here. Okay, so this one is actually wedged in there, which means the chains or the tensioners are trying to go that way. So what I'm going to do is I'm just going to turn it to relieve that in a little bit. But first I got to take this guy off before I go trying to turn anything. And that one fell in, but it doesn't mean it's gone. All I got to do is flip the motor over and it should come out this end, I hope. But that one's sitting down there. I'm not worried about that. It is stainless steel. I can't just use a magnet to pull it out. If you have non-stainless, that would be ideal. Or you have the proper things that go on the valve covers, that would be ideal. So I'm going to go ahead and turn this a little bit. Just wiggle it back and forth until I can hopefully gain something out of here. Okay, so there's that washer and bolt, but I do not have the nut out yet. There we go. Nut is probably going to fall. Oh, great. So before I do that, I'm going to go ahead and rotate this. I know nothing's caught in the timing chain components, so I'm not worried about that. I just want to make sure the timing's good before I get too far involved with trying to dig those out of there. I'm really uncomfortable with how little effort it takes for that chain to jump over that sprocket. That is not a normal amount of effort required. So I'm going to go ahead and pull some tension every so often on these guys. The mark is still lined up there. That mark is still lined up. That one kind of did a jump, that's why I'm double checking that. There we go. I'm trying to get those little locking latches as far back as possible, so that'll prevent it from jumping. So all that hissing you're hearing right now is the compression leaking by the piston rings. That is normal, and that's a good sign if it's doing that. That I did not like. Obviously you guys heard that. In theory, it should still line up, but I'm going to have to turn it backwards to get it to line up. And in theory, these things should hold it into place. Since I did not like that sound, I'm going to go ahead and, well, try and turn this backwards. It's starting to loosen the bolt. Snug it up with an impact, of course. I'm going to be replacing this bolt anyway. It's torque to yield. So now I'm going to go ahead and turn it backwards and see if my marks still line up. Got to turn slow or it's going to take the bolt loose again. Alright, so that snap sound must have been the chain flopping against the guide here, which is not a big deal at all. That's normal until the vehicle's actually running, or to kind of do that from time to time. So all the marks still line up perfectly fine, I guess. I'd rather be paranoid and recheck it than end up with it jumped. So I'm going to go ahead and turn this thing all the way around a full revolution, and the marks will be off, but as long as they're off the same on this chain as they are on this chain, I know I'm good to go. So we'll be right back when I go to put some oil pan stuff on and torque down all the mains and stuff like that. Well, that was quick. I'm back. I haven't done anything on the bottom yet. The noise was not the chain smacking. It happened another time, and then another time, and I'm going, what the hell is that? So I started really paying attention to this corner because that's where the noise is coming from. And it's actually this variable valve timing actuator. These little pins here, this is the separation point or whatever, you know, these kind of shift. That's why there's this big coil spring here. And what's happening is as it gets to a certain point where the cam does its switching of which thing is applying spring pressure to it, so it gets on the other side of a spring, this solenoid or actuator will actually flop. So it's only happening to this one, which tells me this one has bled out the oil that was in here. So normally there's a bunch of oil sitting in there, and if there's oil in there, it'll kind of just go slowly. It'll be quiet. You won't even notice it. This one has bled out the oil, sitting here for as long as it's been sitting. It's been sitting over the long weekend. We had a holiday weekend recently during this motor build or motor repair. So that one has been draining the whole time. Now it goes thunk. Why these three haven't drained, no idea. But I just wanted to cover that. So now we'll go ahead and get to the other side of things. Alright, timing chain thing is all done. That's good to go. I am now to the point where I'm going to start torquing some things down. I have the new main bolts all in here, and I applied oil to them. Of course, put oil on the heads, that kind of procedure. Now, this one I left loose on purpose. Now, Ford has a specific procedure because they only have a thrust washer on the rearward side for the cap. Now, the block side, there's a thrust washer shim type thing on both sides, and I assume that that's just because most of the thrust that's applied to this thing is going to be towards the one direction from the transmission side or something. I don't know. I'm not sure why they only do one thrust on the cap, but whatever, they do. It's the way it is, so it's the way we have to deal with it. So what they're suggesting is to put the crank furthest forward, try and put the cap furthest backward, tighten it down, making sure you keep it in that kind of a position. However, what I have done is I actually took and I put the crank back as far as I could. So I pulled it back, and then I took and I walked the main cap down, I let up, and then I pushed the main cap back against the crank. Then I took a pry bar and I pried the crank forward so it would push the main cap toward the front to make it flush with the other thrust washer. So both thrust washers are flush up against the crank, and now I'm going to go ahead and torque everything down. So that's kind of the procedure I took. You could do it Ford's way, you could do it my way. I think my way is going to be a lot easier. With that, I'm going to get started getting things torqued down, and then we will get to the main girdle plate thingy, and I'll torque those down, so on and so forth. So I lost a couple of video clips, but they weren't that big of a deal for a video clip. It was simply just me putting the oil pan on and describing how to properly apply RTV to an oil pan of such nature. I will have to make a video on that in the future that is not a corrupted file, hopefully. With that, like, share, and subscribe. Be sure to hit the notification bell so you can see the next episode that comes out next week. And I'm out. Hope you enjoyed the video, and thanks for watching.